to prove the tangent of a unit circle with a radius of 1. Now Anton will take over.
Yeah. So first off we have the unit circle here, and we've drawn a triangle using the origin O to the point P, and then drawn a line down perpendicular to the x-axis. Then we've also drawn a line over here that's tangent to the circle, and we're going to try to prove that this, the line from here to the x-axis is going to be equal to the tangent of the angle A, which is over here. Now, first off, we're going to use the relationship of similar triangles, and we can use this because the small triangle that we get in here, this one, is the same as the big triangle. It is because we have a right angle here, and we also have a right angle here, and since they share the angle A, then we know that the third angle is going to be the same too, so they're similar. Therefore, we can use the relationship that A over A1 is equal to B over B1 equal to C over C1. Now, A being the long side, or A being the opposite side of the angle A in the big triangle, and then A1 being the opposite side of the angle A in the small triangle. So first off, we know that A, that's what we're trying to prove, that it's equal to tangent of A. So we're going to write tangent of A. And it's going to be over sine of A, as that's the side A in the small triangle. Now for the side B, that's going to be the opposite angle to this, or the opposite side to the angle up here, so that's angle B. So in our big triangle, that's going to be equal to 1, as we are doing this in a unit circle. And then the small triangle, well, that's just going to be the cosine of A. Now the side C doesn't really matter, but we can put them on anyways. We don't know what the big C is, as we don't have a length on this one, so we're just going to use a question mark for it. And then we know in the short triangle that it's just going to be 1, because it's just a radius of the unit circle. Now, as we want to prove the tangent is this line over here, we're going to have to use this part of the equation. Now, just write it again. Now, since we're trying to find out what the tangent is, we have to isolate it, and we do that by multiplying with sine on both sides of the equation. So we have tangent of A over sine of A times sine of A equals to 1 over cosine of A times sine of A. And when we do this, then we see that these two just cancel out, so we get tangent of A. And over here, well, we basically just multiply an integer with a fraction by multiplying the integer with the numerator. So we get sine of A over cosine of A. And since we know from previously that this is a relationship that's true, that tangent is indeed the sine of A over cosine of A, then we know that this is also true, that tangent of A would be this line here, because that's what it says.